Yeah, let's jump directly into our first demo. I will be the attacker, I will be the bad guy, and I will try to move into Srija's environment. And I hope she will prove me that I'm not that skilled as that I'm thinking. So what I want to show and start with is SAP provides an application which nearly every company has exposed when they're using SAP. It's called the SAP Router. And this SAP Router itself should simplify the access, or it's more from the past. Think about from 1992. It's more from the past. You didn't have these VPN access and that much at scale. So you want to have a simplified access for your users to your SAP environments. And with the SAP Router, you have one single port and one single point of entry to move into your environment and access the applications behind. So fantastic attack vector. It's always there. I try to move through that. And then let's see how far we can get within that corporate environment. From a flow, as you can see, we're on the cloud attacker side, moving to that SAP router. I have no idea what's in between. I only know that IP address. And from there, I will try to move to an SAP system on behind. So what I want to start first is I want to start with a Metasploit module specific for that SAP router. It's used to get some more information. So SAP Router offers the capability to dump the whole route table, which is fantastic for an attacker. Use that module. I already prepared some options for that using our public domain for the environment. And directly, let's try to run that. And what you directly can see, okay, we have to prove it's an SAP Router. Fantastic, we know where we are. And we want to, or the tool is sending that ADM package to get these route informations back, but it hangs so far. So maybe it takes some time. So maybe as a background, that environment is not running in the US. So it's running in the Europe side. So maybe we have some latency or something. Let's keep that away and move a bit on. What I have as a next is SAP Router itself provides not only the capability to route these SAP specific applications. That's what a lot of people forget about when they administrate these SAP Router applications or SAP environments. SAP Router is basically able to handle every TCP-based protocol. And SAP Router itself provides some abilities like an ACL file, which you can configure to, for example, only allow encrypted communication or not. But we did a recent research and we found from more than 9,000 public reachable SAP routers, 300 of them were able or allowed to dump these connection tables, which showed us, hey, more than 300 SAP routers are maybe from a patch level later or older than 5 or 10 years. So there's definitely a problem because often it's a forgotten component in the corporate environment, fantastic vulnerability. And what we will do here is we use this tool here to connect to the SAP router and try to scan the environment behind. So doing a simple port scan to in that case, legacy SAP port, the 3200, using a talk mode called NI. So SAP has its own protocol encapsulation. So that's a network interface. And we use that because in that case, we try to find an SAP port itself. Let me run it while I'm talking. So what will happen here is we connect to that SAP router or sending a package to it. And the thing is here, the SAP router will forward it for us. So this also provides us maybe some invisibility within the corporate environment. Often SAP router itself are controlled by the application team, not by the security and networking team. And yeah, they also need the awareness for that, which is maybe a lack of skills in that case often. So what we found really quick, we found definitely a machine. I didn't start scanning at the first IP address in the range because cloud has some reserved IP addresses. I know it's on Azure, so it doesn't make sense to scan the first 3 IPs, right? I found an IP address here. Okay, we have an SAP system, fantastic. But let's keep a simple attack vector and let's take that IP address and let's scan for SSH access. Because maybe the ACL files are not really configured on that SAP router. For that, I use a different talk mode, which is the raw mode. So now I'm not encapsulating within SAP NI. I'm now sending a raw TCP package, which could be anything which is TCP based, like SSH or whatnot. Just to prove, also that port is open. So I think we have found our victim, Srija. Let's see what we can do, right?
Please go ahead.
Yeah, so I don't have direct access to that system. So I need, again, my SAP router. And yeah, let's set up a port forwarding through that. And which is pretty funny at that. It's not like you would think about it port forwarding or setting up a VPN tunnel. It's more every package when I send it, get the information, go to that SAP router, and from there, please extract your payload, which is in that case that SSH package, and forward it. So it's really some package encapsulation so we hide from other systems to look like legitimate traffic. Let's set up the tunnel, or like a proxy, and let's start our brute force attack. I use in that case simply Hydra. We run on Azure. I think one of the most common Azure username is Azure user. And I use a password list for that. As I set up the proxy, everything which is sent to localhost port quad 2 will directly forward it through the SAP router to my SSH machine. And yeah, let's run that. And while we are talking here, let me hand over to Srija and now prove me.
All right. So before I actually jump into what has happened on the FortiGate, we could see that there is a quarantine monitor here, and I blocked the SAP router you have used to continue the attack. So the reason we have actually set it to 1 minute is because of the time with the time here, but you could actually increase how long you could quarantine the attacker. So we saw that. Now let's go to the firewall policy. So I'll go to the firewall policy here. The first policy, which was actually in effect, is the SAP inbound SAP router. You could see that he'll be able to, the sources, everything, and he was actually getting to the SAP router, which is the destination. And then I was allowing the service called SAP router. But what Julian didn't see here is our IPS and also the app control service attached to this policy. And if we go to the logs, which are matching that policy, there is all legit traffic here, right? The SAP router, this is because he's using the SAP protocol to connect there. But if we scroll down here, there is a UTM blocked, our Unified Threat Management IPS system, which is the IPS, has blocked that he's doing something fishy. So that's with the first attack. In the second one, what Julian has actually done is, in order to trick me, you have used, instead of his public IP address, he pretended to be the SAP router. So that's because we have another firewall policy, which we have configured here to get from the SAP router to the SAP systems. And then I have also allowed the SAP diag protocol. That's the protocol which is used for communicating between the SAP router and the SAP systems there. That's why he was allowed. And like I said, the attacker, Julian, stayed invisible so that the FortiGate wouldn't actually find that he's initiating from a IP address or a public IP address. And again here, with the segmentation in place, with a FortiGate segmentation feature, there is an IPS signature here that is tied to this. So each and every time the traffic is going from the SAP systems or from SAP router to the SAP systems, it's being inspected here. And then that's where the IPS is again coming into place. Now, if we go to the matching logs, you would see that there is this policy violation because not only that he's actually trying to reach the system with the legit traffic before, he's also he's doing something fishy with the SSH brute force, and then FortiGate was able to catch that with the IPS. Now, in order to make it easy, right, and visibility is the utmost important thing so that it's easy for us to see what's going on in our infrastructure. So we have a view called FortiView here, and if I go into the FortiView, we could see the IP address, which Julian tricked, being a SAP router. And then the threat he has actually caused is the brute force attack or the brute force IPS signature it has matched. And then we are blocking that traffic. So that's what has happened, Julian. And then let me actually summarize this with this next presentation diagram here. So Julian thought that he could just get to the SAP router, and the SAP router would go back to the SAP systems. But what you didn't see coming is we have a FortiGate in place. And every time, like I said, the traffic has to go to the SAP systems behind the SAP router. It has to pass through the FortiGate, and the FortiGate is inspecting that traffic. So what defense mechanism is FortiGate using for this attack is the IPS signatures for the SAP protocols. And what is the benefit you're actually getting here is that cloud providers are not aware of this kind of SAP protocols, and then they don't have any IPS signatures in place. Whereas FortiGate's advanced, the FortiGuard services is actually getting the IPS signatures with AI and machine learning, and then it could catch the real-time threats and block attacks like these, which are invisible. And what are the other aspects of dynamic agility here, or the automation that you could tie into this attack, is that we have a fabric connector for SAP systems, which is actually pulling the objects of the dynamic objects or the IP addresses of the SAP systems in the network. So that's, and we'll be talking about the SAP connector in our next demos.
I think what's instructive is that, and the takeaway is how this is different from a cloud provider capability, right? Because we want to be a value add to that cloud provider. Our FortiGate is approaching this by trying to understand what applications are running, right? So this, in our example, it's SAP, could be whatever your app is. Understanding what kind of protocols and traffic that service is using in real time, and then applying tailored controls for that. So something that you wouldn't necessarily get from a cloud first-party firewall service is understanding that he actually did a Trojan attack, spoofed the IP of the internal IP address to hop to something else. And we were able to catch that through just best practices and being able to understand that application's, the way that application operates. Does that make sense? Mm-hmm. Right on. Okay. Thanks, guys.
So, Julian, I'm going to give you another chance. Show me you could do better now.
Let me give that a try. I have some ideas. So, another idea. I know the way through work, right? So let's see, maybe, okay, SSH wasn't that idea. It's a bit common. So I know we can walk through, and I know there's a FortiGate, so we need to stay that stealth. So, okay, but what I could do is, okay, not attacking now the SSH port. Now let's attack the application itself. Let's look like a legitimate user. Maybe we are a bit motivated user because we try and have many password tries on that in fast time, but we are looking like a user. And from there, if we could break that, let's jump to a different SAP system. Let's jump over anything which could be behind. Again, starting here, setting up a proxy through the SAP router. And yeah, I'm a bit a lazy guy. So I don't want to type passwords manually. So let's set up a brute force attack here. Quick one. Let's try if we can find something simple, which is a bit more complex on SAP. SAP is a multi-client application. So on SAP, you could have around 1,000 different companies on it. So now, welcome guessing exactly which is the right client here, right? SAP helps a bit. SAP delivers by default two clients, 000 and 001. Fantastic. And many companies directly starting using 001. Also some guesses, but as you can see, it works. And bad thing here, and by the way, Srija, you definitely should talk with your application team. SAP star is like the root user on SAP. So jackpot. Let's do something cool with that. And let me grab that password. I have prepared here the SAP GUI. So let's do some lazy user interaction. I've prepared that system already. We will go through the SAP router. That's the so-called SAP router string on SAP. So we go to the SAP router on demo-lab.msft.sh on port 3200. And from there, we say to router, hey, please put all the packages over to our SAP system. Let's connect to that. And yeah, seems very well. Let's log in with our phone credentials. And okay, maybe not too good the guess. Yeah, right. So two wrong guesses. Maybe next time better. Sorry.
Okay.
let's jump in. So we are in the SAP system now. So what would be the next step? We want to move to another SAP system. And in the past, there were some interesting attack vectors from SAP system or between SAP systems. And one easy one would be misusing some existing communication. SAP systems can communicate through all over the world. And there is, for example, the so-called RFC connection management. So remote function calls, fantastic. You think about HR and FI systems. They need to exchange data. I think we all want to get our money at the end of the month. So if we're existing as an employee, we should also exist in the FI system with our bank account. And what we could have it here is we check first the SAP internal own connections. And what a bit sticks out is that to NPL. So we see on the down on the right corner, we are in the A4H system. So SAP identifies system with a 3-character SID, and that NPL looks like a different system. So, and if we have a look there, it's, looks like exactly where we want. It's a different subnet at the end, or it looks like that. And if we do a connection test, we have a check, but it's also available. That's fantastic. So seems like our system, which we have compromised, we can move on to the second system. But that's the wrong type of connection. What we would need is SAP is not only handling its own type of RFC communication. Again, SAP is fantastic in doing everything else again too. So if you have an SAP system, it allows to communicate with everything. And there are TCP/IP communication connections. And also scrolling down there, we have a communication to the NPL system. So we could now try to take exactly that, because that has some, it's really old, not really a vulnerability, it works as designed, but it allows us to execute operating system commands unauthenticated. And again here, SAP provides some mitigations in form of an ACL file. But again, who maintain these ACL files and how? From my past, from pen testing SAP applications, I know it's common to have a 10.0.0.0/8 subnets mask in that, which is basically fantastic. Everyone in the company is allowed to access that. It's quite a lazy job for the application guy. It works. So let's take that and try to get some remote code execution. Also, SAP for sure has a transaction for that. And let's quickly add that. We need to start with a set. Let's be some visible here. And we don't know if it's Windows or Linux. Take whoami as a command, works on both, right? And just to prove that it works, execute it on our local system. So you try to prevent me to get an SSH access. I use it that way. So all good, no worries. So we have SSH, local access. We are on the local user, fantastic. So, but it works also remote. And that's what is pretty cool and helpful in the SAP world. Select our connection. And yeah, that should then normally work.
You can sit there and keep watching.
Okay.
And I'll show you what's going on there. So again, Julian didn't see one of the feature of the FortiGate here, and he tried to reach further and access further the SAP systems in the network. So the firewall policy here is the SAP systems to SAP systems, where you could see that the systems will be able to reach or send traffic between each other. And we also have an IPS signature for the prevent SAP attacks. And if I again show you the matching logs, you'll see that there is the SAP RFC. Initially, you did try to be legit, but you weren't. You did something fishy there. And then the FortiGate again did flag that the RFC as an attack. So what exactly happened here is that usually in organizations, right, you have a trusted zone and you would say, just allow the traffic between all this trusted zone, or between, or if you say in the cloud, between the spokes, right, the east-west traffic, you would just allow them because that's again a trusted zone and inside the network. Now, for this traffic to be inspected, we again are having the FortiGate and it's applying the IPS even to inspect the traffic. think of it if it happens to in a real world scenario, right? The attacker is already in, and he could operate in stealth mode, and then could spread the infection way further, and then could get access, causing a lot of disruption or exploits, correct? So the segmentation feature is actually, again, inspecting the traffic, and the IPS is being applied there for the east-west traffic in the cloud between the spokes. Again, the IPS signature and then the segmentation in place. But what happens if you are actually, it has to be applied to n number of systems. Say you are using auto-scaling in cloud. Maybe it's a Thanksgiving, and then you actually have few systems running in the night, and then by next day in the morning, you would like to increase the number of systems, right, in the cloud. Then you don't want to have someone manually go in there and then create this firewall policies where you could add the systems, but you need something dynamically that would pull the information when you are scaling your cloud environment. So for that, we have an Sdn connector in place, which is actually pulling the information of your virtual machines, your virtual networks in cloud, and subnets dynamically. And I will show you the Sdn connector here on our FortiGate. So we have external connectors tab here. And if I click create new, you'll see we have various Sdn connectors that are basically, you could use those to interact with many cloud providers. And you could see the list here. And also not only the public cloud providers, but also any private Sdn or third-party applications. You could use this Sdn connector and dynamically get this information, and also apply the in-depth defense there between the traffic that is within the trusted zone.
Yeah, I think it's also worth pointing out, this is a two-way communication. So when we have these connectors into these environments, and even applications, we can push changes into those software-defined networks. So, for example, in this example, we're pulling information about the objects and information in the software-defined network. But what if we wanted to make a route table change, or we wanted to quarantine an IP or a VNet altogether? We could tell the infrastructure to do that. So, as an example, I could, black hole a route for a VNet until that VNet has been inspected by the security team, as an example, right? So we can actually manipulate the public cloud environments from our apparatus, from our FortiGate in GFW. So that's something that I wanted to point out. Thanks.
Thank you, Aidan. So I just wanted to show how the dynamic objects look. So this is an icon where it's actually pulling the information from Azure for the SAP systems. And just to summarize, what we have seen is that we did talk about the internal segmentation feature of the FortiGate, and also the dynamic object information through the Sdn connector. So what you're actually getting is agility, security, and visibility for your, for the applications running in the cloud. Now, we've been talking about complex systems like SAP, but what if we actually want to protect something non-SAP, right? Like you would have a lot of applications that might be running in your infrastructure, and say you are actually hosting those applications in the complex systems like Kubernetes. How would you actually protect those applications? So this is here we are actually focusing and demonstrating FortiADC, which is our application delivery controller, and it's an advanced application delivery controller. For this demo, I picked two features which I would like to demonstrate again: the agility and the dynamic dynamic feature. So one of them is the automation stitch on the FortiADC. What an automation stitch could do is it could automate an action in response to a certain trigger. So say a security event is actually triggered in the applications that are running in cloud or in Kubernetes clusters, then you would want to have an email sent to the administrator, so the administrator knows about the threat of when it was actually initiated, and more information about it. So you could use the automation stitch for that. And say if you're actually using the Fortinet's integrated security fabric, then the other thing you could do is you could actually ban the IP address of the attacker and push him from the perimeter, from the FortiADC itself, even once it detects the attack. I will actually demonstrate that. And one more thing is that you can have as many, one or more actions for one certain trigger.
Now we've moved beyond SAP, right? This is something that's running, like you said, on Kubernetes or some sort of container environment. And now we're going to be trying to trap these particular types of activities.
So it's not only for Kubernetes, but usually any applications other
any
than
application.
Any applications.
Okay. Awesome.
And this is the feature where you could automate based on the log. So say a security event is actually generated. You could trigger something, say, make an API call to a third-party system. You could do that.
Okay.
You know, so
for mitigation, or is this the threat, or is this what we're trying to mitigate? I'm a little confused.
So the way it's basically to mitigate, right? Like so that you will have visibility into your infrastructure.
Okay, that's what I thought.
Yeah.
Great.
Thank you. I was talking about Kubernetes, and I know most of the organizations have been using Kubernetes for scalability purposes, right? And then you have like, again, non-SAP applications here I put together.
Sure.
So we have the K8's Sdn Connector. So say you have applications running, and then if you have to expose each of the services to the outside world or to be accessed by the users, then you would need a load balancer for each of the service. Say you would be going with a public cloud load balancer. Then that does reflect on your cost, right? Obviously, your manager or someone would be really mad at you because that's going to be a lot of cost for each of the service to be exposed with the load balancer, with an external load balancer. So FortiADC will serve as a layer 7 load balancer that could expose your services running in the Kubernetes. And in order to pull the dynamic or the object information dynamically, we have the K8's Sdn Connector on the FortiADC. So the Sdn Connector is API based. It is actually doing API polling to the control plane and then getting the information of the services that are running in the Kubernetes. And once the services information is pulled, right, the user will manually go onto the FortiADC and create virtual server objects, because the traffic, when it's being accessed from the outside, it will hit the virtual server, and then whatever the load balancing algorithm, say round robin or a weighted round robin or any of the load balancing method, whatever you choose, will be applied there. So that's what happens here, but the user has to manually set all of this content routing, the virtual servers, or create them. So we took a step forward because this is perfect for the organizations where people are more security savvy and may not be Kubernetes savvy, right? Just creating the Sdn Connector. But what if the organizations are more Kubernetes savvy? Like the new feature we have added is a FortiADC Ingress Controller. The Ingress Controller will actually be running on a pod. You could install this with the Helm chart. We have a publicly exposed GitHub repo for the Helm chart where you would be using it to install this and run it on a pod. So the FortiADC Ingress Controller will intelligently update or give information. It will list and watch for the services, for the pod, and for the node information. And it will let the FortiADC know the changes in real time. And the second thing is, it will also convert the Kubernetes objects into FortiADC objects. So what we saw before is that the user is actually creating this objects manually, but since we took a step forward, it's going to create automatically for you on the FortiADC itself. The other thing is when you actually make a change to a service, update it, or scale it down, it will automatically reflect it, and I'm gonna show that in a demo. I just put a slide again to show the differences one more time. So the FortiADC is periodically polling and getting the information, making polling to the server API. of the Kubernetes, the control server API, and the user will go back and then create the information like the virtual server and the real server pool information. And if you see here, the service information is already dynamically pulled. But in case of the Ingress controller, the Ingress controller is actually is converting the information since it's watching and listing the services or changes in the Kubernetes cluster, and FortiADC is getting updates in real time.
So it looks like it's essentially participating in the service mesh inside Kubernetes. Is that right?
Yeah, similar to service mesh, because if you're actually having a service mesh, then you would start to have a load balance instead of using one single load balancer or multiple load balancers. The service mesh does help you to expose with a single load balancers, right? So it's actually doing that job for you, correct?
So would it be compatible with a service mesh architecture, or would I want to choose the FortiGate ADC method of doing stuff instead of a service mesh?
You could do that because you're getting a layer 7 load balancer, and also you're actually having this Ingress controller, which is combining the capability of the Ingress resources along with Ingress load balancing. The architecture which I'm actually using here is the setup here. So the traffic, when the attacker will initiate the traffic, is going from the FortiGate through the FortiADC. And I've set up 2 Kubernetes clusters. One is tied to the Sdn connector, and the other one is to my Ingress controller. So they are actually, this represents the fabric connector, and that's how it's getting information from. And the other thing I wanted to mention is that our Ingress controller has various type of ingress. So it could do content routing. Say, if you want to deploy a service in one path and also another service in a different path, it does do that. It's called a simple fan out, where you will have one IP address that would be exposed, and based on the content, the traffic will be routed, or the content routing or the path-based routing is possible with the simple fan out. And that's what I'm going to demonstrate here. But we have others like TLS, simple backend, and other types of ingresses we do support as well. This is our FortiADC here. And then here is the real server pool. I have the service too, which I'm going to make changes to. And if I click here, and if you want to see what it looks like, is that it has a service on a node port right now. And then I'm going to add a different port to that service, and we'll see how it's going to get the real-time updates or real-time information. And this is, I'm only demonstrating right now the Ingress controller. So let me log into my Kubernetes master here. Right, I just have a replacement, service replacement YAML file ready. So I'm adding this port here to my service, and then I'll just do kube control replace -f. And then I have in my namespace here. And there you go. It just replaced the service. And just as a matter of fact, we'll refresh the page. The Ingress is listing and watching. And then we'll see the new node port. I have added the services it's listening on, or the service port. Like Julian was pointing, this is actually in Europe. So you see that. So there it goes. So it did update the FortiADC real server pool information as soon as I added that node. And again, let me showcase or show you how so it's running on port 8084. Just for the sake of sanity, let me go here. If you see here, I have the Kubernetes simple fan out running on 8084 port. And let me hit that in. So I chose DWA.
Nice.
Just to demonstrate few attacks. And then this is another simple service, JSON running just to show the content or URI-based path routing. So I will actually do an attack, because one other feature, what you're actually getting with the Kubernetes or the FortiADC Kubernetes Ingress Controller is that we have a web application firewall integrated. So say you're actually going with a cloud provider's load balancer, right? You still have to get a web application firewall and tie it to your infrastructure. Whereas with the FortiADC, we have the web application firewall integrated, and we also have other modules like antivirus and DDoS, etc., which is actually, the advantages of it. Yeah.
And I'd be quite familiar with Fortinet firewalls and other aspects of security fabric. The ADC I've not been exposed to. What are the main differences there between the functionality of the FortiADC versus, say, VDOM and proxy mode, where you were providing that kind of web application firewall functionality?
The web application firewall and
the web application.
The WAF, right? The Fortinet's WAF.
But the proxy mode functionality coming in, what's the ADC doing that the other two aren't?
That the FortiGate can't do?
Yeah.
Well,
the
FortiADC is completely distinct. The FortiGate has basic ability to support server pools and do proxy functions, but it's not really dedicated to that service role, right? So the ADC is doing layer 7 load balancing, application-based load balancing. It's applying web-based or web app security specifically, right? So you're thinking of OWASP and type attacks that the FortiGate's really not, it can do some basic things in that regard, but it's not purpose-built for that.
Yeah. What mechanism is updating? What is it? The Kubernetes layer integration there that is backfilling?
Yes.
The settings?
Okay. Right. That ingress controller is backfilling the policy and doing all. So what Srija was demonstrating really was one of two ways that you can approach this. If you're a traditional security practitioner that's managing security infrastructure, you want to do that from the application delivery controller side, the ADC side, you can do that there. And you can pull in those objects. Or if you're more, just managing the Kubernetes environment and you want to not manage the security components, but you need to feed those objects and policy and configure the ADC itself from the Kubernetes side, you can do that through the ingress controller.
Okay, and they're not showing up as MAC addresses or IPs, so they must be pulling actual tag values.
Yes.
Okay.
Exactly.
Okay.
Tag values and yes, other
based on labels as well. So this is the Sdn connector, and you wouldn't be able to see the ingress because it's actually running in the Kubernetes cluster. So just to add on. So I will actually generate a SQL injection attack here. Click that there. And then you see a 403 forbidden because I have a web application firewall tied to my the virtual server, which I showed earlier. So if we go back there, I just want to pull up that view so you could see that there is a web application firewall section. So if we go to the security, I have the WAF profile, which is doing is protecting from SQL injection, cross-site scripting, and also brute force, which I'll demonstrate shortly. Now, let me do a brute force attack from my external machine here. I have already had this command that I pulled over. So I'm using Hydra again, the THC Hydra for the brute force. It's actually trying to brute force so that the attacker could log in by the passwords that might be vulnerable, or that could be maybe the smart guesses. So I'll run this. And since we actually spoke about the automation stitch, right, and then how we could push the attacker out of the perimeter of the FortiADC, I'll show you that. So if we go to the security fabric and the automation, I put this here, the FortiGate ban IP. So what I'm saying is that if you are seeing an attack, and if the type is a period block, because I did a period block for some time, if someone is doing a brute force, then just ban it on the FortiGate as well. So if we go back here and then go to the quarantine monitor, you will be seeing the IP address of the attacker. That's exactly the IP address of my Kali Linux machine, from which I tried that Hydra brute force attack. So that's how you could use the automation stage. And this all is helping, right? Like you have Kubernetes clusters running in cloud, and you have the applications running, and also the automation stitches coming into place where you don't want the administrator to do anything manually, but everything is being done with a security fabric integration and the Sdn connector.
So what does that look like to the attacker right now? What does the attacker see?
Yeah, so if I had to actually try to access from this machine, right, within this 30-second, it expires because I said that I shouldn't be able to get to my application. So it should block that. But let me see how fast I could be.
Trust but verify.
It actually takes time. Like it's not loading here because I'm quarantined. So after that expires, I should be able to get back to that screen.
Gotcha.
You can actually do block as well, but I just quarantine.
Right.
Yeah.
So I want to bring you back to a bit of SAP. So I should technically wear an SAP hat, so sorry for that. So what Srija showed you for microservices, you could also bring that a bit over to critical business applications, like in that case, SAP. So you need to scale them out. And what Aidan already mentioned, SAP in that case is, or every SAP customer is forced to move to S/4HANA or S/4 systems by 2027. And if you think, well, that's far away, you take an SAP project and try to migrate an SAP system, you think, oh, shoot. We are definitely too slow. We need more time. And exactly for that, and providing also the complexity and ability for SAP, and now bring that together with on-cloud and scalability. And there it comes to definitely huge, yeah, it's complex to say that, because you have the SAP application guys and SAP itself, it's crazy complex. And then you have the networking and security side, which is definitely exactly the same complex field. And now you have to bring that together. And these are normally two teams in a company, which maybe if you're lucky, they meet at the coffee maker and they talk with each other, but not really about business objects, right? It's only maybe because they're friends. And that's exactly what we wanted to combine with our solution here for FortiADC. So again, giving you a quick overview how the infrastructure look like. So what we have here is we stay in our setup here. I use the same FortiADC setup, but in that case, I'm switching a bit over to the different connector. So what we have built is an integration for FortiADC to get required load information from SAP systems itself, understand which web services are available, to feed this information automatically back, provide also information like virtual hosts, which are configured on the SAP side. So you as a security guy doesn't need to be aware how SAP works and what there is. And for example, if some SAP administrator decides we are out of resources, I will spin up 10 more instances. No, you don't worry about it. ADC will take care of that for you. You only need to know what you want to publish at the end. And that's exactly what we build up here with FortiADC. And just to give you a quick overview how this looks like, I took my example system here and provided a more different style of diagram. So we have our FortiADC with that connector. And what SAP provides is a so-called message server. And that message server naturally takes the control over who or which servers exist, which load is existing where, and where should I load balance to. And if you think back, well, what I use the SAP GUI application, you normally, if you have multiple application servers, SAP GUI will reach out to that message server, will get back to which server it should connect and reach out to that one. So that's working fine. But now think about you're having a web shop like Amazon, and you now have one SAP system because we're at one web page. And every customer, all millions of customers running against that message server, it's one single process. I think that process is definitely one of the unluckiest processes ever. So because too much load. And that's exactly what we do. But we ask that message server process, hey, please give us that information to our ADC. And from ADC, we have ADC itself is scalable. So you can scale it out to multiple additional instances. ADC itself provides ability to integrate into a GSLB, to be more on the global load balancing level. And so we get this information like which login group exists, which servers are there, which configuration is there. And then we could take the traffic from our client, which is coming through, and send it over to the next available server. For sure, everything which HTTPS, and if required for security inspection with on-the-fly decryption and encryption to have a look in what is suspicious or not. And just to map that back to our infrastructure and give you a quick insights on how the infrastructure looks like, I want to demonstrate you right now, is I've set up the system, and the one you see on the left here, that message server and stuff, has a bit more of a complex environment. So because SAP makes it even more complex, SAP allows to dynamically generate web ports. So what SAP is doing, when you set up an SAP server instance, it gets an instance number, which is a 2-digit number. And based on that, you're allowed to set up ports. So if I configure port 80 instance number on my global SAP system, doesn't mean that everyone, for example, is using port 8000 for web traffic. Every instance now has a dedicated web service, so which makes it a bit confusing. But you're also able to define global ports, which are static. And all these information chained together need to be extracted. And that's exactly which makes it also a bit more complex for non-SAP administrators to understand that. So bringing that information more together. So what I've prepared here is, again, our FortiADC environment. And let me just show you the security fabric for the security fabric connector, how it looks and how easy it is to configure. You already saw that Kubernetes connector, right? And right there, there's the SAP connector. What do you have to provide to get all the necessary information? Give it a name, give it an update interval, provide some connection, for example, the IP address, connection information, provide the required ports as they're dynamic. So we decided we provide some default ports, but leave it open for everyone to adjust how it's required. And in addition, we need some credentials to get the required configuration out of the system. So what we never do is writing anything back to SAP. So that's what we never want to do. We only want to get information out of that, just to don't affect the business critical application and the integrity of that, right? So, and from there, what we simply do is going to the server load balancing, to the real server pool. And let me show you how simple it is. Let's create a new server pool. Let's call it test. And we want to say, okay, it should be dynamic. Say dynamic, and okay, in that case, it's quickly selected already the NPL system connector, which I showed you right now. But what you can see here is a pre-selection, what is possible. So you can even choose, okay, in that case, I want to have everything from everywhere, right? I don't have configured any virtual host. So it's a wildcard there, it's an asterisk. For example, I say, okay, I know that service or what is required is on port 8080. So I have no clue which service this is. Let's select port 8080. Let's select that. Nothing more to configure. And let's save that. And let's scroll down, maybe refresh quickly the UI, give FortiADC the quick chance to get some information. And let's jump into the test. And as you can see, on our test, it selected the right servers, added them automatically, and they're here. So we can now use that load balance our traffic to that. And the only thing which is missing for that right now is we need a virtual server. And I have prepared one on port 8090. Let me show you how that's configured, but it's basically exactly from the complexity. It's totally easy. It's easily fast to set up. We want to do layer 7 load balancing. We have it enabled. We have provided a name. Switch over to general. And to focus on what is important, we select here that real server pool. So if we shut down startup in the backend of the system, it will effectively change there. But we don't care what happens at the backend, right? Only the SAP team needs to keep up one system for that. Let's select our 8080, for example, here in that case. That's a different one, but same selection. But what comes now in addition? So ADC is not only load balancer. Srija mentioned that to you. And that's exactly the point. So SAP itself provides the so-called SAP Web Dispatcher. It can also do and understand that SAP native load balancing, and you can get that application for you. But what the thing is, who maintains that? It's most times the application team. And what does the Web Dispatcher not is basically security. So it's only for providing a single point of entry, combining the load balancing, but you don't have real security applications or something like that. And that's where we come in addition. you have a question?
So, most of the SAP customers that are large have SAP systems running everywhere. They're global, different regions, right? In the cloud. We've seen a lot in Azure going test dev, bringing their, transporting those things onto on-prem for their prod environments they have running on Big Iron. I'm assuming all this stuff can be run as policies. It can be distributed everywhere, so you can have the same protections. You're not doing it in one place and having to do it another, so that it just you're protecting the entire SAP landscapes globally in an organization, right?
Yep.
Right,
so you could also, for example, take multiple ADCs, as I mentioned with the GSLB, with the global load balancing service. You make it worldwide available and load balance between also these resources and manage them centrally. It would be possible, yeah.
Okay, and would this at all coordinate with maybe your SD-WAN appliances and things like that? I mean, is there any coordination with that, or is this purely the ADCs and I guess also the FortiGates, because you've got a lot of components there that could build kind of this fabric, the SAP fabric that's just kind of in its own virtual network globally, separate, I guess, segmented from the rest of IT, the generic servers and VM farms. People like to keep their SAP stuff away from everything else for good reasons, because it's got the crown jewels of an organization, right? So, is it possible does this configure or integrate, I guess, with the SD-WAN and FortiGates into a fabric that can segment that, among other things?
Definitely, for sure. So all of our products are integrated into that fabric. So as Srija mentioned with that automation stitch as a simple example. So when we find something on ADC, we could trigger actions on another device or feed that information back into our fabric. So there are, based depending on the product, there are very other ways where we can feed that information further. So and then decide on basically what should be or could be done. Or Aiden.
Yeah, so this is a sample use case. Typically, customers are going to be running a myriad of applications, either homegrown or off the shelf. SAP is one of the more complex ones. But to your question, it's exactly what we can do. So think of the users who would have to connect to these environments now because they're working from home, they're working from remote offices. You have SD-WAN on-ramping into cloud environments, right, that would connect to this type of application. And so the FortiGates are all interconnected, providing, in many cases, SD-WAN, acting as SD-WAN hubs, right, and coordinating all of that connectivity, and then bringing those users into that environment. And then, so we can share this context and information across the entire IT footprint. So as an example, if you have a data center, if you have a colo, if you have a remote site, right, I can feed the information I'm learning from this cloud environment into those locally, so that now I don't have to do all my decision making and waste money spent sending traffic to this environment. I can make the decision in the local environment closest to the user, so we can distribute policy and have a coordinated policy across the IT estate. Does that make sense?
Yeah, well, that's why I asked the question, because I mean, this is all fantastic stuff. It's just, and it's very detailed and it's granular, and usually, guys like us eat that up. But in this particular instance, when you're dealing with such a, you were talking about the tree, the branch on the tree, when the real value is in the forest, and what you're able to provide, which you're providing the whole landscape of SAP, which is it's a bear to manage it as it is, and it's all full, as you've shown pretty well, it's got full of security holes. So to be able, and being one of the most important applications in an organization, to be able to protect that globally, all the instances in an entire landscape for a Fortune 500 company is kind of important, right?
Yes, sir. Yep, absolutely.
WAF profiles, mentioned that already. So we can protect, we provide. So, and that's exactly the thing. SAP is not always like every other web application. It has some specific stuff. So we also provide there's some signatures specific for SAP. Like there were recent attacks. Maybe you heard of them also. The recon attack, for example. Often they have some high CVSS scores because it's critical, affecting such critical data and crown jewels, right? And our mission is exactly to prevent such attacks and help companies to secure their applications, that nothing like that could happen to them. In addition to that, what we try to bring is, or what we bring is visibility for what we have. And that's exactly, Srija already showed it also on the FortiGate. Now let's show it on the FortiADCs, FortiView. So what we bring here is a bit more of a graphical view, because we often don't only have a look on the CLI, we also maybe need a quick diagram to understand how something works. And just to shorten it quickly, let me show you how that, for example, looks in that case for our SAP environment, what I've provided here. Here we go, it's the last one. You can see it here. So we have our virtual server here provided. It's a bit of a cutted name, but here we have the virtual server configuration. And then we have that real server pool at the end. And on that real server pool, we see, okay, we have right now two available instances. So if I now maybe shut down one instance or maybe dies or for whatever reason happens, right? Or maybe someone spin up because good day, we have some money over, let's set up 10 additional cloud instances for today. That money needs to get out of the house. That's exactly what we can see. Quickly, dynamically get an update on that and see that. And just to show you a bit of that load balancing, I've prepared here for you, sorry, it's maybe a bit small URL, but that's an SAP info page which shows you on which server you are connected right now. And you can see we are on the AAS1 server, right? So on the first edition application, and now we switched over to the second one. But we stay persistent now on that second one. If we now go over or back to my terminal, because I need a separate IP address to really maybe show some second mobile user for that use case, let's see where we land. And as you can see, we're not on server 1, we're on server 2. So we load balance between those two. But what happens now when I kick off server 1? What happens then, right? And we quickly can do that. Let's stop that SAP. What happens, right? I mean, it's only an additional application server. Let's shut that one guy down, give it some seconds. And ADC will recognize, okay, no, that machine is now gone. I don't get any information from you now. I will load balance you back over. I think that's all what we expect from a load balancer, right? Hopefully. That's exactly what we can do with that. So system is stopped. We have a look here. We were on system AA2. That's fine. If we have a look here, let's refresh our logical topology. You can see the last one. Okay, it's already gone. So quickly had a quick update. And if we now switch back to our previous command here to show that user, we are now on the second server back. If we would start it back up, would automatically and dynamically get that back. I think you know where I want to get you there. So, and that's exactly what we built for SAP and specifically in that case for us. So as it makes it quite complex to handle this environment and also for non-SAP savvy guys, that's exactly why we have that here. But before we end today, we want to show you something again with Deceptor and one last attack. Before I pay the beer for this evening for Srija. So let me try something at the last time. And now we want to bring it more in the end. And so what I'm doing here is I target SAP on some legacy stuff. Web always works. And let's attack the web application here in that case. So I want to move directly. I forgot what I had before in mind, right? There's a firewall and something like that. I want to attack now these SAP applications. So there's this SAP web GUI. Maybe I have a login field. Let's see maybe how I can move in there. So let's have that here. I already opened the page. I published on 8090. So I have it here. And when I see a login field, the first what comes to my mind is an SQL injection. It's always my 90 time. It works quite often. Let's keep the simple one. Make a true statement. SAP ones definitely have a password. Don't know what I typed, something in there. But okay, something happened here. But yeah, I got in. So it seems a bit like you're not that secure, right?
German engineering.
Do you want to grab some information while you're there?
Yeah.
That would be the point of it all.
Let me see, right? But to be honest, I jumped right in.
Okay.
Why happened that?
So,
what's up? So, I mean, it's fantastic. You don't need to pay for the beer, but
You may have been deceptored. Hopefully.
Exactly. Yeah, I'm going to show it to Julian what happened. Since you tricked me in the first attack, right? I tricked you now. So we have used a FortiDeceptor running in the cloud. So if you see, can you go back and show the page of the port, maybe after I talk. So he got redirected to a decoy VM, and he's actually not in the production system. It's just a trick that he was redirected back in there, but the attacker thought that that's the actual production system. So the FortiDeceptor helps us to install or to actually have where the decoy VMs are hosted. So we chose the SAP decoy VM, and then the FortiADC is the one which actually redirected when it detected an attack. So the attacker, again, Julian, the cyber criminal, didn't see that coming. So what happened, he just thought, it's a FortiGate, and then there might be another system, or he didn't see even the FortiGate, but he just thought he could get directly into the SAP system on here. But the way it happened is that he got to the FortiGate, and he went to the FortiADC, where the attack, it detected the WAF attack, because there is a WAF there, and it redirected back to the FortiDeceptor decoy VM. So there is a SAP decoy VM running, right? So what actually have done with that is that we have custom Lua scripts, which you could actually write on the FortiADC and then attach it to the virtual server. So in this case, we have attached the Lua script to the 8090, which is the SAP application. And it said that when a WAF attack is detected, redirect to this decoy VM. That's the Lua script it's saying in the background. And he got redirected. And why didn't we block him, right? We could actually block him and not redirect him. But what if the attacker could do threat mining? Maybe he might have advanced tools which we could hack more into the system and then get a hold, right? We just wanted to trick him and show, actually spoof him with the entire network or the production system or the user. So that's what it is. And the FortiDeceptor is actually our deception-based breach protection system, again, where you could deploy this decoy VMs. And it's basically an advanced honeypot. That's what I would say, just to make it simple. And that's how the FortiDeceptor is helping there. So if I go back to, I'll show you the FortiDeceptor here. All right, so this is the FortiDeceptor dashboard. I'm already logged in here. So you could see that there is some incidents that have been flagged. It's a threat incidents, like we have seen Julian he was redirected here. And if we actually go to the incident tab and analyze this, right? You will be able to see that there was an interaction, and this is the IP address of the hotel here, which is the attacker's IP. And then it actually went to the virtual or the victim IP. This is a network or a VNet that was set up, isolated, which is isolated VNet. And then that's where the FortiDeceptor is actually running. So he got redirected or to that decoy VM, and that you could see here. If we actually open this one, right, you could see what all the attacker have done, a post request, and the information about the attack, the flow of the attack.
With FortiDeceptor, what we want to do, we want to catch people who are trying to do more than only firing up a script. And where could you do that better, or what is important? So as the shift to the cloud, so we want to bring Deceptor to the cloud. Now, think about, you have deception-based these decoys on the cloud, and okay, fantastic. You have nested virtualization maybe there because you need a manager. You have these virtual machines. And then you have these extensive, huge machines on the cloud, which is definitely not that helpful maybe also for the cost. And what we built here is exactly the opposite. So you have a central management appliance and small footprinted nodes in the cloud. And these small footprints there in the cloud, they're cheap, they're simple, and they're communicating to the manager. So you're actually, where I walked in, is a machine which running in a totally different area and definitely not in the cloud. It's running out there. But it looks for me as it working in the cloud. And I got the catch. And so what we also can do is, for example, handling some new ransomware attacks. So what we are not able to for only hosting web servers or something like that. Deceptor is more. So we can, for example, provide so-called lures. So you put it on a Windows or on your corporate device like Mac, Windows, or somewhere else, and treating the attacker who could maybe compromise that machine, maybe with ransomware, to encrypt files on a share, but this share or a decoy. So we detect, hey, there's someone trying something suspicious. There is some files encrypted. Okay, they not exist, but they're there. And what should we do now? And that's exactly, we come back to our fabric and automation integration, because Deceptor can talk with our solutions. Not only ours, we can also talk with, for sure, other vendors like Cisco, Palo Alto, and so on. We integrated there. And what we can do is we can isolate that client. We could enable our incident response team. We can enable our EDR and bring exactly that functionality there.
And I think to point out that it's more than just a honeypot. What we're creating is an entire application environment. It's not just, you know, a VM that's being spoofed. It's multiple virtual machines potentially. It's the networks on which these virtual machines run. It's the protocols spoofing, you know, communication between devices, and it's spoofing users and all of that activity. So it looks like to an attacker like something very, very real. And we've actually, in our testing, have tricked you know, people outside the company, and it's been fun. But
this is a Lua script which I was talking about. So this is a custom script, and we already have, you know, so many predefined ones. But this one, which I put together, it's a custom one, and I'm saying that when a WAF request attack is detected, then you could redirect to this IP address or the URL. You could even have host names there, or but that is actually a decoy VM on the FortiDeceptor.
What is different here, so we don't do a redirect when every time someone tries an attack, it's a persistent redirect. So because we want to have the attacker think about a brute force script, he will to ping that port always again, right? But he needs to automatically always get redirected. Think about brute force and something not. So when the attacker one time hits that WAF, it was his last chance. So basically my last chance. So I now always get redirected to that honeypot, which by the way
creates that rule.
Exactly. So that's
all traffic.
Exactly. So we move him over a bit.
Think of a practical real world use case. You have a globally distributed cloud environment, and you're under constant attack, right? We want to not just use and consume global threat intelligence, which is kind of generalized. What we want to do is create threat intelligence and understand what's happening on our own in our own environment, right? So we're looking at essentially a kill chain of activity that's happening. We're using that, and then we can send that out and use that information to raise our security posture overall. Think about a use case where password lists are compromised all the time, right? Let's say we load your corporate LDAP into this FortiDeceptor, which we can do, and somebody is using making password brute force attempts, and they happen to use an actual real user's password and username. Well, you know that now, and you say, well, I know I've got actual users who are compromised, and you can quarantine proactively if you wanted that user from the network to say you're not secure, change your password, we'll let you back on, or just notify them. Or maybe you have a bigger problem where an entire list of passwords has been compromised, right? But that's a practical real world use case. And everything we've demonstrated for the most part today got rid of manual push button workflows. Like this was all automated information feeding between systems. And so I hope we drove home the point that we can create a more agile security environment in cloud by automating these things and integrating with the SDNs and the applications that we support.